Yeah.
Okay. Okay, let's start.
Okay, welcome everyone to our Tuesday, August 4th session for our education session. In today's session, Simple Rholang will be continuations as second parameters to receive. This will introduce recursion on the evaluator. Tomislav, it's all yours.
Thanks. So for today, as Steve mentioned, I want to show extension of our Simple Rholang that we were developing in the last few sessions. So the idea is, I will share my screen. First, I want to show in comparison with the previous version and this new version. So what changed? So basically, just with a little recap from previous sessions. We have this in our Simple Rholang. We have these four operations. Nil is a stop process, par to put processes in par, send and receive. So we don't have quote and unquote that we have usually in Rholang, but we will add this later. So for now, we have only these operations. And for today, we have just a small extension. So the nil and the par stays the same. Implementation will be a little different, but send and receive are different from the last time. I mean, the last session, I was trying to introduce this another parameter to send, which now I applied to both send and receive. So from this previous version that we were running, this is the main difference. This another parameter to send and receive. So how this will reflect to our Simple Rholang language, this is the point of today's sessions. Do you maybe have some questions now, or maybe some questions for previous sessions, or anything you have in mind? Do you want to see something? I mean, for me, it's much easier if you ask me any questions or direction. If I'm just talking, then it's much harder for me. So this is why I'm asking. So please, if you have anything, please ask me or stop me.
Yeah, actually, we need Lamouette here as well. He's a pretty seasoned programmer. I want to ping him, see if he's available, see if he can join us. So let me do that.
And this is why I'm going very step by step for each of these extensions. So we can talk about something that we've seen previously, but also this new stuff. Okay. I don't see who. Oh, Rafael, is that you?
Yeah, I was just writing a message to send to Raphael, and he must have mental telepathy. He and didn't even hit the send button. Welcome, Raphael.
Hello, hello.
Hi.
So okay. So how we can implement these additional values that we are that now that we have for send and receive, and what is missing from like a full Rholang, because there is one part that we still don't have. So so this is what I want to show. So let's see. Our operations are changing the internal state, and previously this state was these three classes: a par for storing all of the processes in a set, and send and receive for each operations of send and receive. So now that what I mentioned last time, I was not completely sure what to do and what structure to use for this state with additional parameters for send receive. And at the end, I decided to use the very similar structure that we currently have in our real Rholang code. And this is to completely remove this send and receive classes and encode this send and receive as part of our par class as the different fields. So what this basically means, how we are, what we're going to do when someone is calling send or receive, we are create the par and put the same thing, like these two processes, because these two methods are accepting completely the same arguments. So the idea is to separate sends and receives in the separate fields. So we don't need like the special class to say, this is the send and this is the receive, because this is they are not part of the same set or the same collection. And here they are in different fields, so they are in different, well, not set, but here is the list. I will say why I choose list and not set. And they are in separate fields, so this is why we don't need these additional classes. And also, I added this special field where we can collect just the process itself, like these ground terms that we have. These ground terms are like primitive types that we have: string, integers, tuples, or in this case, some system processes. So now everything is inside our par. This is our complete state of our language. So whatever operation we execute, we will modify this state, or we will store our object in this state. ToString is overridden to print everything very similar as previous. So for send and receive, we don't have special class, and we are just storing the sequence of tuples or collection of tuples which represents name and value, or in the case of receive, name and our continuation process. And to override ToString, I wanted to show something that we can easily recognize when we print our expression that we created. So basically, there is nothing new here. This is just the new is just different structure and how to print this new structure in some way that it's easy to understand. So previously, here was inside the par, our state, we have set, and this set was erasing whatever was duplicated. So if we had two sends that are sending on the same channel, we will have only one, because set will erase this. So now I wanted to have like more to be more close to the real Rholang. So now all of the terms for example sends or receives, they are collected in a list. So this is not completely correct, because semantics of Rholang says that if we have two sends in par, we can change the ordering, and this is still the same program. So now when we are collecting this in a list, theoretically we still don't have this equality of the different ordering. So I just want to mention that this is our next step to implement equality of our expressions. So if we are comparing two pars, two par as two classes, we need to sort all of these terms in each of this field, so that with this sorting, we are basically saying if we are sorting always in the same way, and if we are comparing this structurally, if we will have the same, two processes will be equal if the structure is the same. So if we have two sends, this sense will be equal. I will show this as part of our example of execution of this Rholang. Is this?
So just to repeat what you said there. So with the send, so with the par, it doesn't matter, you know, what side the argument is on, what side of the par the argument is on. When it sorts, are you saying that it's always going to sort the same way? So that's where it doesn't matter what side of the par that it's on?
Yes. So let me go there and try to write some programs. So I want to remove this one, we don't need it. Here is our execution. Okay, so I have already something here, but I will write a new example. So if we have send on some process A in par with some process B, and I'm using this pipe, which is not always working as expected. So sometimes I need to add nil to say this is a. Oh, no. I need to send something. This is the correct syntax. So now we have the channel and also we have the value. I forgot about that. So let's have these two examples with if we are sending something on A par B, and we want to, for example, compare these two programs. This should be completely the same program, right? Because we are doing exactly the same thing. We are sending on the same name, and we are using the same value. And Rholang semantics is saying that this is completely the same. If we are using the semantics of par, is saying that B par A is completely the same as A par B. This is just the two processes executed in parallel.
Right.
But when I execute this, we will see that this is false. So this means that we are not implementing our semantics of Rholang correctly. So this should be the same, and this is not the same. So why is not the same? Because send, when executed, it will create a one element list. Each of this call to send will create a one element list. But the name inside is also a par. So when we are constructing this par, and this par is A par B, we will concatenate, I don't need this here, we will concatenate whatever we have on the left side of the sends to the right side of the sends. And the same thing for receives. So basically, in our par, we are collecting sends, receives, expressions. So when we are putting things in par, we are combining whatever we have in the left sends with the right sends, left receives with the right receives, left expressions with the right expressions. And we all combining this inside one par. And this is basically our operation of combining, this monoid operation of combining. But we didn't implement any ordering. So, and this is why our expressions will be in one case A, B, and in another case B, A, right? List of A, B and list of B, A. And this is why every term in Rholang is, it's ordered. I mean, all terms are ordered. So for exactly for this purpose, to implement equality between terms. So if we are ordering our list of sends, list of receives, and list of expressions always in the same time, always in the same with the same algorithm. When we are comparing two pairs, we will get the same result. This makes sense, because A will always be previous to B. So even if we are creating send A par B, the ordering will be AB and let me write here. So our sends list will be sequence of A and B. And in this case, we will still have BA as a parameter that is supplied to our par. But when we are ordering this inside par, we will at the end have the same sequence. So when we are comparing these two sequences, we will get the same result, and these expressions will be the same.
So this ordering, that is a component of Rholang, or is that the component of Scala?
Yeah, this is a good question. How we are ordering this? I mean, this is easy for strings. Ordering of strings is already implemented in Scala. But how we are ordering case classes, this is not defined. So why I'm not using some ordering here? I could say, oh, let's be sorted. And now I have the problem. Because maybe here. So now I have the problem. I didn't implement ordering trait for tuple of process. And to implement that, I need to implement ordering of tuples, ordering on processes, and all recursively, basically all for all terms that we have.
So for as we write code, that is something we want. We want this ordering to happen in order for this sends to, in order for it for the computer to understand the sends. So well, anyways, continue on.
Exactly. The point of sorting this is to implement correct semantics, so that both of these terms will be the same. Because this is what Rholang is needs, right? Rholang specify that.
Okay, so it needs this. It needs to know that this ordering the sequence A-B. So we have to set everything up in order for that to happen.
Yes. Greg is explaining this as part of rolling semantics. Usually something like that. You probably seen this many times when Greg is saying this is completely equal. So
Well, I guess what I'm trying to wrap my head around is this idea of ordering. Things. If things are in order, that means they're going in sequence. But in a world of rolling, everything's in parallel. Things happen concurrently at the same time. So I guess I'm trying to reconcile. In one world, everything needs to be in order, in a specific order, and go one after the other. But in this other world, in the concurrent world, things happen at the same time. So I guess we have to have things in order, in sequence, because we're using Scala, and it's a requirement. I guess. Having things concurrent, that I guess that's not the way the computer works. It has to be in sequence, not concurrent. Is that right?
Yeah, you're very, very close. And I exactly want to try to explain this.
Okay.
Ordering is not really necessary for rolling as a language.
Right.
But just by thinking about the set, for example, Haskell implementation of set. To where this is the best visible. Okay, so in this implementation of a set, is this big enough? So in this implementation of a set, and this is usually the case. I mean, usually maybe the easiest way, or just to think about that. Set is a structure that recognizes the same elements, right? So, for example, if we have a set of characters, A, B, C, how can we know that two sets are the same? For example, so I'm creating a set of A and B. Is this equal to a set of B and A? So this is totally unrelated to rolling. I'm just saying I'm creating two sets.
Well, I would say, they're similar but not identical.
But semantics of a set is saying there is no ordering of elements in a set.
Oh, okay.
So
okay.
Whatever in whatever order you put elements in the set, there is no difference, right? Okay. The set doesn't recognize the ordering of it just recognizes the same elements, and if you have the same number of elements in two sets, and these elements are the same, these two sets are the same.
Okay, very good.
We can also see and this is maybe best to show this difference. So when I ask Scala to show me what I have in these sets, right? So I constructed these two sets in different order. But when I ask, what are these sets? Oh, Scala is remembering ordering. So this is like a strange thing, and showing me the ordering that I supplied elements. So I was expecting that elements will be sorted, and so this maybe tells us something about the implementation. But what I want to point out is in Scala, if you want to add element to a set, you need to supply implementation for ordering of your elements. So what this tells us? This tells us that implementation of the set depends that these elements are ordered. So we can imagine, for example, situation like this. I have list 1 and list 2. And I will basically do the same thing as here. Oops. But now I think this should sorting should work. Okay. And now is list the same? List 1 and list 2. So what do you think we will get now for this equality between these two lists?
So if we're saying that sorting or order is important now, then it should be false.
But look, both of these lists will be sorted in the same way.
Oh, okay. So if we're telling it to sort in the same way, then they'd be the same. But I guess if you know, if we have sort AB and sort BA, which one do we have to designate one sort as the default?
The question
is, notice sort AB. How is AB take priority over BA? Would be. Yes,
this is an excellent question. So you're asking, there is some kind of magic here. You're not showing everything,
yes.
Right? Yes,
right.
Yes, this is correct. Because if you remember, these implicit arguments for sorted function. So I will now go to look sorted function, and sorted function it has another argument. If you remember from maybe very first or second session, these implicit arguments doesn't have to be specified, but this is exactly what you are asking. Who implemented sorting for strings? Who said that A comes first before B?
Right.
So this is like an excellent question, because yeah, this is not specified here. So when we ask IntelliJ what else we need for sorting, IntelliJ will say, yeah, you need ordering for strings to be defined, and this is already defined in Scala. So I can go there and I can see implementation for string ordering.
So we did it with the implicit ordering early on. We said that, okay, we want A to before B in any type of sort. Okay.
Yes, and how you implement this? You implement one function where you say, if I give you two strings, you need to give me the result of ordering, which is less than, equal, greater than. For any string that I give you, you need to give me this integer value -1, like the ordering is reverse. 0, both strings are equal, or 1, which means that the ordering is correct, right? This is the first element, this is the second.
Okay.
And this is why I said I didn't implement this directly here, because I didn't implement ordering for all of the processes that we have. Because this process is our custom type. So Scala gives you ordering for all the primitive types, like integer, strings. So you don't need to implement that by yourself. But if you are creating your own types, you need to say how you are comparing these types.
Okay.
So now you asked how this is related to Rholang, because in Rholang, whatever is in par, it doesn't matter which ordering we are writing. Execution is non-deterministic in this way. We don't know which file we execute first and which second. So this sorting, all this business of sorting is not for Rholang semantics, is for implementation. So basically we can say, yeah, we can implement our own set, but all the elements will be always sorted. So whatever you put in your list, we will always sort elements in the same way. So when we are comparing two lists, you know, we are guaranteed that if they have the same elements, they will be always, these two lists will be the same.
Okay.
Does this make sense? How we are using ordering in the same way how in Haskell implementation of a set, using ordering to implement this, you know, equality of different.
So, yeah. So let me just kind of summarize what we just went through. So in our world of Rholang, where we have concurrency, you know, things happening at the same time, you know, that's the foundation of Rholang. But in order for that to happen in the real world, you have to use a functional program like Scala. And Scala, it doesn't work that way. It wants things to be in order, in a sequence. It has to be a specific sequence. So we can write in Rholang, we have that freedom to have A, B, or B, A in par with one another. So we have that freedom to do that and understand that it's going to be in concurrent. But what's really happening, the magic underneath the hood is in Scala is it's actually still being ordered into a sequence.
Yes, we want to have this ordering, so that we can implement correctly this Rholang rule.
Okay. Okay.
So we don't need ordering for execution of the program, but if we want to compare these two names, for example, if we want to match, is this sending on the same name? This is important because if we are sending something on one name and receiving something on the same name, we have comm event. So if we have sending on A par B and receiving on B par A, and if we are not recognizing that this is the same, we will not see comm event. So basically, this is why we want to order all of the terms. So when we compare, is this the same channel, we can get the correct answer. And this is the property that we want to use when we are doing this matching. So this is like a good introduction to our evaluation of these terms. So let's write something. Let's write some comm event. So this is our program 5. So let's send something on A par B, something, and let's receive on A par B. And whatever is received, it doesn't matter right now. So this is our program 5, and let's execute immediately this program. So we will evaluate this prog 5. So let's see what is the result. So basically, we already see that we are sending and receiving on the same channel. So in our naive implementation, what will happen is we will erase the send receive. So the prog 5 will not be anything. And this is also like a little bug that we have in toString, because if we don't have any, if our par is empty, maybe we should just write nil as an empty process, because now we are not we will have empty string, and this will be printed as empty string, so we don't see anything. So this is something that we can detect here is if we don't have any expression, we can display nil. I mean, we can implement this right now. So if our all is which is a complete string created from expressions, if this is empty, we can display nil, and if it's not empty, we can show what we have. So let's execute this. Oops. Maybe we don't have empty string completely, but I'm not sure why. Okay, I don't want to go into that right now. This is not important. But basically, we don't see send receives, because comm event happened and we just erase what we had. So just to show that why we need this sorting, I will change the ordering. And now, because our language is not completely correct, it doesn't implement correctly the semantics of Rholang to p par q to be equal q par p. And now we will see that we still have these processes. Our program is still the same. Nothing happened. So we have send receive as we started. If we implement sorting on our sends here, when we are combining this in a par, there will be no difference between A par B and B par A, because all the time sends inside our state will be sorted. So whatever you put inside, if you are putting the same elements, they will create the same list, and this list will be the same, and they will when we are comparing this for comm event, we will find out that these two names are the same.
And this is the methodology. When we were talking about Ripple, and they were looking for other languages to incorporate. So whether it's and I don't know what the base language they use in Ripple, whether it's C, C++, Python, or whatever, it's this same methodology which would be implemented in other languages in order for Rholang, Simple Rholang, to have the elements of par for sending and receiving on both channels.
Yes. Whatever language do you have? If you remember, Greg is mentioning multiset as something that we can store our terms. And multiset is basically doing the same. If we have multiple elements which are the same, we will just say how many elements we have. And multiset doesn't exist. The implementation for multiset is not part of the Scala like basic library. So I wanted to have like the most simplest way of implementing Rholang. So I'm not using any additional library, and this is why I'm using just a list to concatenate.
Okay. So Scala didn't necessarily have some of this architecture library elements built in. So if they're not there, then you have to go in and kind of make them yourself to make all this happen.
Yes. Okay. For example, if you don't have a set in your language already, you can use a list, and when you are comparing two sets, when you want to find out, you know, is they the same, you can sort the element in both lists, and you can compare it and say, yeah, they're equal or not equal. Also, you need to take care of duplicated elements. So you should not allow this kind of stuff, because semantics of a set is saying there cannot be two elements the same. So if you are using a list to implement set, you need to detect when someone wants to insert two elements that are the same, and you need to erase this duplicate.
Mm-hmm.
So we are basically implementing, I mean, you can use the structure itself to implement this part of the Rholang, but you know, if you understand how this structure is implemented, you know, basically you can do it yourself without this additional structure. I mean, you just want to implement the semantics, the correct semantics. So you can use set, list, whatever you want, but if you are using not exactly correct structure, you need to have these additional operations that you need to do. You know, this checking, right? Is all the elements are completely different as in a set, or is there a way to compare different ordering? So I wanted to show another implementation with a hash. So this is another implementation of a set in Haskell. So this is a different library. Mm-hmm. And you see that, for example, insert doesn't require ordering, only equality and hashable. So if you can hash your elements, and if you have implementation for equality, you can use this hash set. So this is a different implementation which doesn't require you to say exactly the implement the ordering. It's only requiring for you to implement how to hash whatever you have this element and how to compare equality. So you know, there is a different way how you specify, you know, how can you store your elements in the different structure. You know, how fast it is. You know, if you are sorting something all the time, this is not very fast. So if you are hashing all of these elements and store the hashes, you can be a little more faster. So, you know, so this is the difference.
So say, you know, in our set, you know, we have element A and element B. So in insert, we hash element A and we come up with a hash, and we hash element B and we come up with a different hash.
Yeah, so.
Mm-hmm. And then with equality says, okay, the hash A is different from hash B. So there, I guess it makes a distinction there that A is different, that the two hashes are different.
Yeah, I'm not sure how they are using equality and hashable in this case.
Okay.
I'm not sure why do you need equality if you already know the hash, because you can compare the hashes. So right. I'm not completely sure why equality is also necessary, but I just want to point out that you can have different conditions for different structure, right? But if in general, if you want to implement set, you need this notion of equality, right? What is equal, what is not equal, or you need to compare elements, or maybe you can implement hash, so that implementation is doing this comparison for you and sorting or whatever. But all of these things is to implement the semantics of this structure, and in Rholang is also very similar. I mean, it's more complicated, but it's also has this defined semantics. Okay. I'm glad that we cover this part of Rholang semantics, and how this is implemented in real Rholang, because it's not very much different. We still have sorting on all of this, all of the terms, and we are comparing the terms in this way. So we are implementing our set. So I want to show. We are now already close to the hour. So I want to show what we gain with this receives continuation. So the next time we can continue this more in detail, but I just want to show what we have now. So let's create our process like this, and we will add for this receive. Oh, I cannot write it like this. Can I write it like this? Yes. And okay, let's send something just on C. This is not important. I want to add something in the receive. And we have these special names. If you remember this standard output, so we can display something. And I will write without the tuple. Just this is our example continuation, right? So let me extract this in another variable. Print example. So basically, I defined one process that should print this text as a special name, and I'm putting this process in the position of continuation. So if this is the same, and I will make it the same. So if we are sending and receiving on the same name, this continuation should be executed. And this another send is just to show that we can have something else. So now when I execute this program, what we are expecting, because we know that continuation should be executed, we should see this example continuations printed out. And this is exactly what we see. And what is left is our send, which is not matched with anything else. So now we have this way of executing something else on a continuation. We still have the question what to do with this value, because we are sending something on this channel and we are executing here continuation. But what is with this value? And this is what is missing. So our continuation is can be any normal process, and this is completely true in Rholang. If we are writing in Rholang something like this, so we are receiving something on A part B, right? And here we are executing our print example like this. But can we receive some argument? And that's the problem. We don't have patterns. We don't have a way to specify in our process how to supply something inside, right? How to how to transfer this value or something that we are receiving here, this X, for example, how can we put this inside the process? and this is where patterns are included in Rholang. So we can create a pattern, and we can say when matching is happen, we can extract the value that we are sending, and we can put this value inside our continuation. So what we have now is just executing the process as continuation. We cannot receive value from the continuation. And we can see here in our evaluator what we are doing. I want to go quickly through the evaluator, because it's similar to previous one, but also the difference is the recursion. So how we are catching these continuations. So first, we are matching whatever we have in our sends and receives. So I will not go today in this function matches, but we are trying to find, this function is here. So we are trying to find the same names. So this is use this match proc, but yeah, this is just helper functions. So we are matching our names we are sending, on which we are sending and receiving. When we have a result of this matching will be whatever is left of sends, whatever is left from receives. But we will also get continuations that are produced when we matched send receives. So the important part, and we also have expressions, and we can execute expressions. But what I want to point out, what we are doing with continuations. We can just detect if there is any continuation left. This means that we found in this round of matching, we found the same send receives on the same channel. So we have continuations. In that case, we will execute or combine whatever is left from our eval in this round of matching with our continuations, put everything inside the par. So this means all of the continuations will be put in a par together with whatever's left of our send and receives and expressions, because here we are constructing this one par of whatever is left of send and receives and expressions, putting everything in par and just recursively evaluate again. If there is no continuation, if in one round we don't have any continuations, that this means that we don't have any matching between send and receives. They are all on the different channels. We just return the result, and we are done. We are done with evaluation of this Rholang term. So we don't have any comm event left to execute. So we are done, and we can just print whatever is left. That was a very quick explanation, but I hope the next time we can go more into details.
Yeah, this is helpful to take a peek behind the curtain to see what's happening. The magic of Rholang and what makes Rholang actually work and do what it does. So yeah, this is great.
And our current evaluator is completely sequential. So we are matching send and receives, and then we are combining continuations, and then we are matching again, and this is all sequential. But we can still say that our Rholang is executed concurrently, right? We can easily shuffle our continuations with all the other sends and receives and say, yeah, but I will not match send and receives always in the same order, and this is like non-determinism of a par. But of course, it's much better if we can execute all of this matching also in parallel, so we can speed up execution. We don't need to wait matching or on some other stuff that if we are matching some other branch. Or, you know. And this is where things become a little more complicated. You know, when you want to execute this in multiple threads, then you need some kind of synchronization on some point, and you know, this kind of stuff.
Well, those are some of the questions that I'm going to have. Yeah, you know, single thread compared to multiple threads. Those are, but I'll save those questions for next week. So I'm going to queue them up sequentially. My questions, and if others have the same questions, we may be asking our questions in parallel.
Yeah, exactly. Yeah.
So we're coming to the top of the hour, and I know I certainly have to leave. Tomislav, this was a great session. I really enjoyed it. So
thanks for questions. Yeah, that is so fun.
Yeah, well, I think I've got. I'm not a developer, I'm not a programmer, but I've got a foundation. I know enough to ask, to follow along and ask those questions. And you're, you know, I feel like I'm progressing.
Yeah, so, I mean, your questions are excellent. Exactly what you know, the core point of what I'm trying to say. So yes.
Very good.
Thanks.
All right. Well, thank you everybody for joining us today for our education session, and look forward to seeing everyone back here next week.
And at
thanks.
2 o'clock Eastern time today, we have DApp developer session. Hoping to get started on the liquid democracy bounty. We can get some people involved.
Great. Thank you, Jim, for announcing that.
Okay.
All right. All right. Have a great day, everyone. See you back here next week.
Thanks, Tomislav. Bye.